Okay, so for this excellent project on my DLP, I chose a challenge problem for our final test, the Unit 6 test. I did it in class, and now I'm just going to show you everything I did. I wrote it all down, but I'll still explain each step. So, the problem was like this. 10 grams of propylmethanoate is burned in oxygen. What mass of CO2 is produced? Okay, so and then he gives us a hint, which is that if we know how to draw the shape of propylmethanoate, it will help us with the problem. So I already had a couple ideas. I was pretty sure I would need to figure out the formula for propylmethanoate, which is why I needed to know how to draw it. And then I realized that I would probably need to do balanced chemical equations because it said it's burned in oxygen. And then from there, I can use stoichiometry to figure out the mass. I'll walk you through each step. But first of all, let's go to the drawing. Propylmethanoate. I know that any compound, any functional group that ends in O8 is an ester, which is characterized by a carbon that is single bonded to an oxygen and double bonded to another oxygen. So basically it's a carbonyl, but a carbonyl that's also attached to an oxygen with a single bond. Okay? So now let's go through the name. Propyl, which means 3, and methanoate, which means 1. So I started by drawing 3 carbons, right? But I know that the part that's connected to the carbonyl is the meth. That's the 1. So I drew 3, and I did these with hydrogens like normal, right? And then I drew my carbonyl, right? That's 1 carbon. And we have the double bond to oxygen, and the single oxygen, and the hydrogen. So that's how has 1, and this has 3. Makes sense. Okay, now I came up with a formula. How many carbons do I have? 1, 2, 3, 4. C4, if you count out the hydrogens, I got 3, 6, 7, 8. I got H8, and then 1, O, 1, O. So O2. So C4H8O2 is our formula. Okay, so we want to find the mass of carbon dioxide. I know that if you start with one thing and you need to find the mass of another, we need to use a balanced chemical equation. And they told us they burned in oxygen gas. So I said C4H8O2 plus O2 becomes CO2 plus H2O because anything that's combustion ends in CO2 plus H2O. Okay, I did some balancing. None of the charges needed to be balanced. They're already all balanced. But I added 4 CO2 because there's 4 carbons, right? I did 4 H2O because there's 8 hydrogens. So 4 times 2 is 8. And then I realized, well, we have only 2 oxygens on this side, but I have 4 times 2, so 8 plus 4. I have 12 here. So I did 5 O2, right? And now if you count it all up, C4, all right, we got 4 carbons. H8, we got 8 hydrogens. And O2 plus 5 O2, so that's 12 oxygens. We got 4 times 2 is 8, plus 4 times 1 is 12. So here's my little trick. We end this with 4 moles of CO2 because our mass is 4, and that's basically telling you have 4 moles of that. Okay, next step, we're about to get to stoichiometry. I'll explain that more in a sec, but we're going to need to know how much 1 mole of propylmethanoate weighs and how much 1 mole of carbon dioxide weighs. Propylmethanoate, you use your blue sheet, pink sheet, whatever you want, becomes 88.12 grams, and mole of CO2 becomes 44.01 grams. Okay, stoichiometry. It's used to convert from one thing to the next, right? So you always start with your given. We're going to start with 10 grams of propylmethanoate over 1, right? And then to balance this out, it's like kind of like an algebraic problem, but you balance out numerators and denominators. So our next thing, the denominator, is going to be grams of C4H8O2, right? So grams up top, and now grams of that down below. And we're going to convert from grams of that. We're going to see how many grams of that is in 1 mole. So I wrote 1 mole of that over 88.12 grams of that, right? Sounds good. And now we're going to convert from moles of propylmethanoate to moles of carbon dioxide. Now you can see on the left side of my BCE, I have 1 mole of C4H8O2, but on the right side I have 4 moles of CO2. So here I'm going to write 4 moles CO2 over 1 mole propylmethanoate, right? Because they balance out. And now last thing, we're going to put mole of CO2 on the bottom because same, like you cancel out. And on top, we have 44.01 grams. Okay, we multiply it out. I hope this makes sense how I've done it all. 10 times 4 times 44.01 over 88.12. And then we do the math and we get 19.98 grams of CO2. And that makes a lot of sense, right? If we start with 10 grams of propylmethanoate and we burn it, it makes sense. 19 seems like logical sense. Okay, thank you for watching.